In this example, we are asked to find values of theta if theta is in the interval from 0 degrees to 360 degrees. And we are actually looking for the angle this time given the function value. So in part A, we are given that cotangent of some angle is equal to negative the square root of 3. We're going to use the function definition to determine what angle between 0 and 360 actually has the cotangent value of negative square root of 3. So we're going to think about this as a fraction. We're going to think about this as over 1. And we know that cotangent is adjacent over opposite. We're going to draw our special triangle, and this special triangle has to have an adjacent side that measures square root of 3 and the opposite side that has a measure of 1. So this is our 30, 60, 90. So we're going to draw this, and the side that's opposite of, let's say the hypotenuse is 2. The side that's opposite of 30 would be 1. The side that's opposite of 60 is the square root of 3. So according to our definition, the adjacent side for this angle, the adjacent side has to be the square root of 3, and the opposite side has to be 1. So we want to know what angle that we are actually referring to that has an adjacent side of the square root of 3 and an opposite side of 1. So we're talking about 30 degrees. This is going to serve as the reference angle. So we're going to start thinking about what we call a reference angle family. So the angle that we're talking about has a reference angle of 30. Doesn't mean that the angle itself is 30 degrees, but let's think about the reference angle family of 30 degrees. So we have a 30-degree angle that lives in quadrant 1, and we have an angle that has a reference angle of 30 that lives in quadrant 2. We're just going to draw all of these reference angles in. So the angle that we're referring to has a reference angle of 30 degrees. We want to know what angle that we're referring to. Let's just name these angles. So in quadrant 1, that angle would actually be itself 30 degrees. In quadrant 2, this angle would actually be 180 degrees. Take away 30 degrees, so that would be 150 degrees. In quadrant 3, we start here at 0 and go all the way around to that quadrant 3 angle. That would be 210 degrees. And going all the way around and stopping 30 degrees short, this would be an actual angle of 330 degrees. So all 4 of these angles have a reference angle of 30 degrees, and they're all between 0 and 360. Now what angles are we actually referring to? Well, one thing that we haven't considered yet is this negative here that's on cotangent. Where is cotangent negative? Let's draw our little helpful chart here. We said that it's all students take calculus. So we're talking about cotangent. Cotangent is positive where tangent is positive. So we're talking about quadrants 1 and quadrants 3. Where cotangent is positive. Where's cotangent negative? That's where we're actually going to look for our angles. We're going to look for our angles in quadrant 2 and quadrant 4. So the angle that has a cotangent value of negative square root of 3 would be 150 and 330. So the angles that we are looking for that have this cotangent value, there's 2 of them between 0 and 360. 150, 330. They both have reference angles of 30 degrees. So I want you to be familiar with what we call the reference angle family. Within a reference angle family, all of the angles will have exactly the same function value except positive or negative depending upon what quadrant that the angle lives in. So all 4 of these angles will have cotangent value of square root of 3, but the ones in quadrant 2 and 4 will be negative square root of 3. The angles in quadrant 1 and 3 would have been positive square root of 3. So these would be our 2 solutions here within that 30-degree reference angle family. For part B, we're looking for an angle between 0 and 360 that has a cosine value of negative square root of 2 over 2. Let's go back to the unrationalized form of this fraction. This fraction has been rationalized. Before we rationalize, the value of this fraction would have looked like this. It would have looked like 1 over the square root of 2. So I want you to convince yourself that if you were to rationalize this fraction, it would look like this, the original value. But if you unrationalize it, it looks a little bit more familiar within our special triangle. So in our special triangle, in our triangles, we know that cosine is adjacent over hypotenuse. So we're talking about one of our special triangles that has a hypotenuse of square root of 2 and an adjacent side of 1. And we know that that would be our 45, 45, 90. So the hypotenuse is square root of 2, and the two sides are values of 1. So within our special triangle, we need this to be the hypotenuse, which it is, and we need the adjacent side to be 1, and it doesn't matter which side we pick. They're both 1s. So we can tell very clearly that the angle that we're referring to is a 45-degree angle. And this is what we would call the reference angle. So the angle that we're looking for has a reference angle of 45 degrees. So let's draw our 45-degree reference angle family. So within each quadrant, we have an angle that has a reference angle of 45. So I'm going to draw in my 45-degree reference angles here. Remember that the reference angle is the value between the x-axis and the terminal side of the angle. So we're looking for all angles that have that distance between the terminal side and the x-axis of 45 degrees. So in quadrant 1, that is the angle itself, 45 degrees. In quadrant 2, 180 degrees, take away 45, that value is 135. In quadrant 3, it's 180 plus 45, that would be 225. And then in quadrant 4, 360 take away 45, we have 315 degrees. So all four of these angles, this is what we call the reference angle family for 45 degrees. All four of these angles have a cosine value of square root of 2 over 2. Depending upon which quadrant, it could be either positive or negative. Well, we're looking for cosine values that are negative. So all students take calculus. So we want where cosine is negative. Well, cosine is positive in quadrant 4 and quadrant 1. So we're looking for values or angles in quadrants 2 and 3. So the angles that we're looking for are 135 and 225. So these are the two angles that have a cosine value of negative square root of 2 over 2. So these will be our two solutions for those angles in between 0 and 360. In part C, we're looking for an angle that has a cosecant value of 2 times the square root of 3 divided by 3. And once again, this fraction has been rationalized, so let's unrationalize that fraction. So if we were to unrationalize, that would actually look like 2 divided by the square root of 3. So make sure that you can convince yourself that if you were to rationalize that fraction, you would get back to this original value. And cosecant is hypotenuse over opposite. So we're looking for a special triangle that has those values as the hypotenuse and as the opposite side. So let's draw our special triangle, and this will be the 30, 60, 90. So the hypotenuse is 2, and let's go ahead and draw on our angles. So this will be 30 degrees, this will be 60 degrees. Across from the 30, we know we always have the value of 1, and across from the 60, we have the square root of 3. So the hypotenuse is 2, it's always 2, and now the opposite side of the angle that we're looking for has to be square root of 3. So this is the opposite side of the angle. So the angle that we're referring to here within the triangle would be 60 degrees. Square root of 3 is opposite of it, and this is the hypotenuse. So we're looking for an angle that has a reference angle of 60 degrees. So let's put 60 degrees, let's visualize it in each of these quadrants. So we have 60 degrees here as a reference angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what are these actual values? Well, in quadrant 1 we know that it would be the angle itself, 60 degrees. In quadrant 2, that would be 180, take away 60, so that would be 120 degrees. In quadrant 3, we go all the way around, 180, and then add 60 degrees, so that would give 240. And then in quadrant 4, we do 360, take away 60 degrees, and that will give us an angle measure of 300 degrees. So which one of these, or which of these angles would actually give us a positive cosecant value that we are looking for? Well, we know that all 4 of them would give us 2 divided by the square root of 3, but we want to know where is cosecant positive. So this is a positive value. So we know all students take calculus. We know that cosecant is positive in quadrant 1, so 60 degrees is definitely one of our solutions. So the angle, one of the angles we're looking for is 60 degrees. We're looking for all angles within the interval from 0 to 360. So where else is cosecant positive? Well, it's positive where sine is positive, so we're looking in quadrant 2. So the other angle that we're looking for is 120. So we want to look for what quadrants that cosecant is positive in, and we're looking at the 60 degree reference angle family. So 60 and 120 would be the solutions.